technological challenge. The old mill, originally built in 1955 to produce pulp from North African esparto grass, was reconverted to process softwoods. Insufficient capacity rapidly led to losses. Should it be closed down? The decision to save the mill and extend it by doubling its output was reached at the beginning of June 1978. And the work began. Three years later, the mill was operational. The technical cost of the operation was over 750 million francs. The bleached soda pulp production capacity for softwood pulps has been increased to 240,000 tons per year, or 1/4 of the national requirement for softwood pulp. As the pulp unit of the La Rochette-Sampa paper division, the mill is now the leading pulp mill in the European Economic Community. The technological challenge has been met by the men of Cellulose du Rhône, who proved their ability to build the mill, a cohesive and reliable production facility with the most sophisticated equipment. The new mill has three main operational areas: pulp production, the wood store, the fiber line, the bleaching chemicals department, energy production and regeneration, environmental protection. These three activities are closely interlinked by various departments: the maintenance shop and store, the offices of the administrative and marketing departments, the laboratories, the staff welfare department, the security department. Pulp production. Pulp production requires a vegetable raw material. Hardy annuals like straw or esparto grass, hardwoods such as beech or birch, or softwoods like pine or fir. The wood must then be processed. The process may be mechanical, chemi-mechanical, or chemical. Only the chemical processes can provide the high-quality bleached pulp required for some kinds of paper. At Tarascon, we use a chemical process known as the Kraft process. We use this process with softwoods. Why softwoods? Because the length of their fibers enables the papermaker to achieve the strength required for the production of these types of paper in combination with short fibers. The entire production effort goes into isolating each individual cellulose fiber and removing the cement or lignin which binds it to its neighbors. This very complex task involves several stages. The softwood logs from the southeastern forests are stocked in the wood store. At the same time, sawmill waste, here in the shape of wood chips, from the local sawmills and cutting centers, is taken in either at the railhead. Here you can see a wagon tipper in action over its hopper. Or at the road discharge point. The chips are selected by the sorters, then stored and lifted from store by an automatic chips pile reclaimer. Debarking. The logs are carried to the debarking drums, where friction between them is sufficient to remove the bark. Chipping. The logs are then chipped by two large cutters. The chips are then stored before being cooked. The bark and sawdust are burned to supply the energy needed in the mill. Cooking. Cooking and the first washing stage are carried out in this Khmer twin-bodied digester, which dominates the country at a height of 74 meters, approximately 245 feet. The cooking dissolves the lignin with the aid of a solution of soda and sodium sulfide known as white liquor. The blending of the chips and the white liquor is carried out in the liquid phase in an impregnator, which is embodied in the digester. After impregnation, the blend of chips and white liquor is introduced into the top of the digester. The liquor is cooked for about 90 minutes at 168 degrees Celsius in the first third of the digester. The reaction between the lignin and the white liquor results in a very dark liquid known as black liquor. Washing. When they leave the digester, the chips are broken up into fibers which form the pulp. The pulp is treated in centrifugal cleaners to separate the knots and uncooked chips which are recycled. The pulp is washed against a countercurrent to remove the lignin initially dissolved in the digester. The washing is continued in the diffuser and the wash filter. Screening. The pulp now consists of quality fibers and is stored before bleaching. Bleaching. The chemically treated pulp is rinsed after each treatment. It takes 5 stages to achieve complete bleaching. After strict checking, the pulp is now ready to be cut into sheets. Sheeting. The pulp, in a very dilute state, is drained by gravity on an endless wire 35 meters long, on which the web is formed. The water removal process is continued through a series of presses, and the web finally passes into a dryer where, on a cushion of air, it travels more than 700 meters. Packing and storing. On leaving the dryer, the web is cut into sheets 80 centimeters square and packed in 250 kilo bales. The bales are then stored for shipment by road or rail to the paper mills. The complete production cycle averages 48 hours, from chipping to packing. 4 tons of chips are required to produce 1 ton of pulp, and the mill produces 700 tons of pulp per day, or 240,000 tons per year with 340 working days. The second operating area, parallel to pulp production, is energy production and regeneration. Energy production and regeneration. The purpose of regeneration is to make use of the black liquor, which consists partly of chemicals introduced in the cooking and partly of organic matter from the wood. The black liquor reclaimed from the washing process is concentrated in a series of evaporators and used as fuel in this recovery boiler, which is 55 meters high and has a rating equivalent to a 250,000 kilowatt-hour power plant, in conjunction with waste products such as bark and sawdust. The recovery boiler is capable of supplying steam to the entire mill, whilst at the same time driving 2 turbo generators to provide the necessary electricity. After treatment, the calorific value of these organic products is sufficient to provide almost the entire energy requirements of the mill. This energy recovery has cut unit fuel consumption by 75%, while pulp production has increased by 170%. During the combustion of the black liquor, a smelt is recovered at the base of the boiler. It contains the minerals originally constituting the white liquor. After being dissolved, the smelt becomes the green liquor, which, after caustification with quicklime, regenerates the soda of the white liquor. This is re-injected into the digester as a cooking agent. The muds produced in this operation are treated in 2 kilns, which produce the quicklime reused for caustification. Environmental protection. Science has always been applied conscientiously here on the banks of the Rhône. Tarascon was one of the first big French mills to implement the new regulations governing environmental protection. The cost of the operation to meet the official standards was 55 million francs. Environmental protection consists in minimizing the effects of noise, atmospheric pollution, and water pollution. The mill was designed to reduce noise to the minimum. The efficiency of its operation precludes noise and smoke. Considerable efforts have been made to reduce air pollution. The beauty of the neighboring vines and orchards is ample evidence of the efficiency of the powerful electrofilters and dust extraction systems. All the evil-smelling gases are collected and burned in the lime kiln. The water treatment installations can handle 80,000 cubic meters of water a day. Water from the production and regeneration facilities is collected in the primary settling tank and then treated in this new oxygenating lagoon, which is 9 meters deep and at the bottom of which injectors blow in air, re-oxygenating the water. And finally, the muds are collected in these last 2 settling tanks, measuring 46 meters in diameter, and burned in the waste boiler after dehydration. At this stage, the water is clean enough to be discharged into the river. The EEC leader in terms of production, the Tarascon mill is also the leader in terms of its advanced technology. All the microcomputerized production processes are centralized in the control rooms and their satellites, the key points of the plant. The fiber line room, cooking, screening, bleaching and chemicals. The bleached pulp cleaning room, pulp presses, packing, shipping. The regeneration room, energy production and waste treatment. The woodyard room. Designed for the year 2000, these systems guarantee for our company a very long life, and for our customers a reliable and homogeneous quality. The regional challenge. Preservation of the natural environment is a constant concern. The annual pulp production capacity has now been increased to 240,000 tons and requires nearly 1 million tons of wood, an extra 600,000 tons in relation to consumption before the extension of the mill. Wood supplies come mainly from the southeast of France. Auvergne, 350,000 tons. Languedoc-Roussillon and Midi-Pyrénées, 250,000 tons. Provence-Côte d'Azur, 215,000 tons. And the rest from the areas adjoining these regions. In order to ensure supplies, priority has been given to 2 factors: the pursuit and development of forestry activities and the setting up of the necessary infrastructure. Forestry activities. The forest needs men in order to live. And men have too much need of the forest to maltreat it. That's why the logs come mainly from diseased or overcrowded trees which could not be used otherwise, or from branches and treetops which are not suitable for sawing, or wood from thinnings removed to enable the other trees to grow normally. It's a godsend for the forest. Did you know that the industrial softwood left unused in the southeast quarter of France amounted to about 1,800,000 tons a year? And this despite forest fires. And despite the parasites. The preservation of the forest is a duty for our industry. The necessary infrastructure. Considerable efforts will have to be made in this field. Too much wood is still exploited using the methods of the Middle Ages. Forestry operation today requires industrial facilities in line with the times. It's the only way to remain competitive and make the operation profitable. Sofo Est, Société d'Exploitation Forestière de l'Est, was created for this purpose. Its corporate aims are promotion of the use of waste, rationalization of transport systems, advisory services to forestry operators, forestry operation essentially in unprofitable areas. This policy will ultimately bear fruit. The river rolls on, the forest prospers, and the two together provide work for men. The development of forestry operations leads to an increase in wood consumption, which, in turn, leads to the creation of 400 or 500 new jobs, which in turn lead to new activities. And the beneficial repercussions for our region are considerable. More considerable, perhaps, than the fact that we've doubled the national output of wood pulp. The social challenge. It needed a lot of faith, a lot of energy, and also a lot of work to get the machine rolling, and to do it in 3 years. But all three challenges have been met. The success of the operation is essentially due to the fact that the men of Cellulose du Rhône were able to combine a change in technology with a radical change in outlook. And that was what was needed to move from steam to microprocessors. The first year, 70,000 hours of training, further education, and a system of enhancing knowledge and improving qualifications enabled everyone to progress at their own speed, as and when they acquired new functions. If sharing means anything, that's the key word at Tarascon. In the rush to get it all started, everyone contributed his know-how, his experience, his ideas. And when the startup was completed, the habit stuck to the benefit of everyone. Ever since the Tarasque, a monstrous animal which ravaged the whole region, was driven out of the country, there's been no lack of adversity. But nothing has ever shaken the faith of the men of Tarascon. And if they're asked why they expend so much energy, they answer, in order to be ourselves.